Okay, so we are going to practice understanding what specific heat is. And specific heat, turn this on. Specific heat is how easy or how difficult it is to change the temperature of a material. Water, for example, if you want to change the temperature of 1 gram of water from 20 to 21 degrees Celsius, it requires 4.18 joules of heat. That's a lot of energy. That's why it is difficult to change the temperature of water. It has this high specific heat. Aluminum, a metal, is very easy to change the temperature. If we have 1 gram, this is the mass of aluminum, at 20 degrees Celsius, and we want to increase the temperature to 21 degrees Celsius, it only requires 0.9 joules of heat energy. That is very easy to change the temperature, and metals in general are easier to change the temperature than other materials because they are good conductors, heat conductors. So here we have different materials, and most of these, actually all of these are metals, some are semi-metals, and we have the value for their specific heat. And so if I ask the question, which material is very difficult to change the temperature, I'm going to look for the number that is the largest. This number here, 1,830, is the largest, and that means that beryllium here is the most difficult to change the temperature. If I want to find the easiest material to change the temperature, that would be the smallest number. And where's the smallest number? This one looks pretty small, 128, but there's a smaller smaller number here, 128 for the specific heat, and that's lead. Lead is the easiest material to change the temperature for these metals here. And this is called the specific heat again, and the specific heat we represent with C. Okay. So if I go here and I ask you which material has the lowest specific heat, the lowest is the smallest, then I'm going to find the smallest number, and that's 128. Okay, and that's lead. I wrote the answer here. If I want to find what is the material with the highest specific heat, I look for the largest number, and that would be beryllium here, 1,830. So I could write beryllium here. Now, number 3 asks me, identify 3 materials that will heat up slowly. So slow means it is difficult to change the temperature. It's actually going to be a large number. So which ones have the 3 largest numbers? Identify 3 materials that will heat up quickly. This means they heat up fast. And that means that their specific heat is small. It's very easy to change the temperature. So I want to identify here the 3 smallest numbers. For number 5 and 6, you're going to describe. Again, yesterday we were practicing describing and writing answers to describe questions. Describe why beryllium will heat up slowly. And you need to say beryllium will heat up slowly because, and then use this number to help explain. The last question here says describe why gold will heat up quickly. And that's number 6. And look at the number and use the number to help explain your answer. Okay, so for the next few questions, these are MCAS. These are more advanced questions. These are A-level. But I'd like you to try them and see how you perform. So for this question here, it asks, a student mixes 70 grams of water with and at 80 degrees Celsius and 140 grams of water at 20 degrees Celsius, that's this, in an insulated cup. So you mix these to get this. The total mass is 210 grams. What is the final temperature? What is the expected temperature of the water after 1 minute? There's more mass here, less mass. That means the final temperature should be closer to this here. but they will not be 20. It will be close to 20, but not exactly 20. And so you need to choose the answer that is close to 20, but not 20. For the next few questions, here you need to calculate. And here we're calculating heat. The specific heat of water is 4.2 joules per gram Celsius. How much heat is required to raise the temperature of 100 grams of water by 5 degrees? Now it says how much heat. If I go here, I can look up heat. In physics is represented with a Q. This is heat. So now I can find the formula for heat. Where is it? It is right here. Here. And this formula is this formula. And under each letter, I tell you what it is. Q is heat. So it says how much heat means I need to calculate Q. C is the specific heat. This is specific heat. M is mass. And T is the temperature. So now let's calculate and determine the value. So if I go here, Q equals M multiplied by C multiplied by T. So C is the specific heat. It says here the specific heat is 4.2. Then I multiply that by the mass. Can we find the mass? How much heat is required to raise the temperature of 100 grams of water? That's a mass. 100 grams. This is joules per gram Celsius. And then we multiply specific heat by mass, multiply mass by temperature, and the temperature here is 5 Celsius. So if we multiply those together, let's get a calculator. We have 4.2 multiplied by 100 multiplied by 5. And that gives me 2100 joules, because heat is energy, and energy we represent with joules. So the answer here would be D. Let's go to the next question. So 2 quarters initially at the same temperature are heated with a flame. 1 quarter was made before 1965 and is composed of silver, it's a metal, and the other quarter made after 1965 is made of copper, that's also a metal. Which information is needed to determine which quarter will heat up faster? Again, the idea of heating up faster. We talked about that. Heat up faster is what we were talking about here. Heating up slowly, heating up quickly. A material that heats up quickly has a small number for the specific heat. A material that heats up slow has a large number for specific heat. But here it says which information do we need to determine which will heat up quickly or fast? We need to know the specific heat. Let's go to the next one. So this is similar to the last one. So here we want to calculate specific heat, or excuse me, heat. And we're going to use the same equation. Q equals M C T. And we multiply those. So I know that C is the specific heat. It tells me the specific heat is here. That's 4.2. And that's joules per gram Celsius. Then I multiply that by the mass. The mass is 200 grams. And the change in temperature. Now, the water change in temperature. The water goes from 20 to 50. What is the change in temperature? When you go from 20 to 70, 20 to 70, the change in temperature is 50. And if we look at that, change in temperature is 70 minus 20, and that should equal 50 Celsius. So here we multiply by 50. If we do that math, I'm going to use my calculator, 4.2 multiplied by 200 multiplied by 50, we get 42,000 joules. Okay, that's this number here, C, 42,000 joules. Let's go to the next one. The thermal energy is added to sample of 15 degrees C water. Which of the following quantities must increase if we increase or add thermal energy? If you add thermal energy, the temperature must increase or change. Specific heat never changes for material. That's always the same. Okay, I hope this helps. Complete the